Distance vector routing with RIP. Distance vector routing protocol is a type of dynamic routing protocol. It uses Bellman-Ford algorithm. Routing information protocol RIP is often applied in very small networks. And it is one of the most common distance vector routing protocol. We will describe the behavior of the RIP and also configure RIP routing and associated attributes. RIP is an IGP, interior gateway protocol, based on the, again, Bellman-Ford algorithm, which operates on the basis of distance vector. RIP contains a minimum number of parameters and requires limited bandwidth configuration and management time, so it is ideal for small networks. Principal behavior. RIP enables the router advertise routing information to his neighbors and only advertise the best routing information, which contain the networks unknown and the distance to reach the networks. Metrics. Each route contains a metric. The RIP metric, is the distance to the destination network. RIP metric is hop, where each hop contains by 1. So RIP metric does not take into account any other factors such as bandwidth, delay, etc. Routing loops and hop limits. Matrix is incremented by 1 before advertise is forwarded. A limit of 15 hops is defined to prevent infinite forwarding. So a hop count of 16 assumes the route is unreachable. So since they have a limit of 15 hops, so this protocol is only good for the small networks. How the loop happened. In this case, router A and C connect each other. Router A advertise 10.0.0.0/8 to C. But when this network fails, the next best route, which is C, it will send the advertise to A and tell A, I know where to get to the 10.0.0.0/8 with metric equals 2. So A and C will exchange this information back and forth, and each time the metric will increase by 1. So eventually a metric of 16 will be reached, and it represents an reachable route. Loop prevention, split horizon. So a split horizon is a mechanism to prevent a loop when using RIP. So the idea is a route cannot be advertised on the interface where which it was learned. In this case, if router A advertises 10 to C, C will not advertise back this one to A. But it can advertise this one to B only. So this mechanism can prevent the loop. Poisson reverse. So Poisson reverse is another mechanism to prevent rip loop. One rip detects an invalid route. It will advertise this route with the metric set to 16 and inform other rip routers. This route is invalid and not reachable. Triggered updates. Triggered updates occurred when the local routing information changes, and the local router immediately noticed its neighbor of the change in routing information. So the triggered updates shorten the network convergence time, because by default the updates are sent about 30 seconds in this period. So this trigger update allows the update to be sent almost instantly. Rip messaging. Rip is a UDP-based protocol. It uses UDP port 520. It sends routing update message broadcast to the address 255.255.255.255. Here is the packet. It's a RIP. So you can see this portion is the message. So you can see the command. It will tell whether the packets is a request or response. In our case, this is a response. Version. So RIP has two versions, version 1 and version 2. In our case, it's version 1. So must be 0. Okay, so after the version, there are, you see the version, and there's a 0000 in the middle. That's this zeros. Address family ID. The address family ID is IP, and there are 0000. That's the zeros in the middle. IP address. We advertise 1.0.0.0. So metric is 16, and the zeros in the middle are those zeros. And you can put up to 25 watts in one packets. Can be advertised in a single RIP update message. RIP extension. Rip 2. The extended fields in Rip 2 are the rod tag, subnet mask, and the next hop. So rod tag, basically you can tag routes. So in order for you to do some process based on the tag. Subnet mask, Rip 1 is a class 4, so it doesn't, they follow the standard class 4 network mask, so you don't need this portion. Version 2 is classless, so you have to specify the MAC address, also the subnet mask. Also, it has next hop information. Rip 2 version 2 use multicast 224.0.09 instead of broadcast to advertise the routing information. Here's the packet we captured. So you can see the source address. Destination address is 224.0.0. 224.0.0.9. So command respond version 2. Route tag, we don't have route tag here, so it is 0. IP address, subnet mask, and the next hop, also metric. For RIP extensions authentication. The authentication configured between pairs must match before RIP message can be successfully processed. So version 2 originally support only simple plain text authentication, but this one have a security issue since the authentication string could easily be captured. But with the increased need for security, crypto authentication was introduced. First to support the keyed MD5 authentication, RFC 2082, and the further support of HMAC-SHA-1 authentication introduced of RFC 4822. Huawei AR 2200 series routers support all forms of authentications. Here is an example of the authentication. You can see authentication use the simple password. You can see the password. So if you have some prop installed in the network, you can see the password. So it's not really secure. So we recommend you to use MD5. RIP load balancing. So load balancing can be used in RIP to utilize the redundant links. AR2200 supports up to 8 equal cost routes by default. We build a similar topology. So R5 have an interface 5.5.5.5.5. R9 have an interface loopback address 9.9.9.9. Let's see all the R6, R7, and R8, they have a identical link here. So from R5, you should see 5 identical link to 9.9.9.9. So on R5, so you can see in the routing table, in order to go to 9.1.9.9/32, you can go to 56.6, 57.7, or 58.8. So which are 56.6, 57.7, and 58.8. So it load balance the RIP traffic. RIP network advertisement. So here is the command. Under system view, you put the RIP, you specify the version 2, and then you put the network command. Here we want to advertise 10.0.0.0/8. It basically says the network command specifies the network address for which RIP is enabled, and it must be the address of the natural network segment, which means if it's private, you have to use 10.0.0.0, 172.16.172.16.0.0, or 192.168.0.0. Even there, the routing protocol itself, version 2 itself is classless, but when you put the network, you just use the classful portion. So RIP metric in. So you can use this command to control the routing. So in this case, if you want to, by default, this one have a RIP, the 10.0.0 has metric 1. So, but you can configure on this interface, change the metric to 2. So in our case, now R5 have 3 load balance paths. So I don't want traffic go to this link, so I can change the metric in on this interface. So R5 gig 0002. So interface 002 RIP metric RIP metric in. So we should only see 2 routes to 9.9.9.9. So you see you have only 2 routes, 1.1, 56.6, and 57.7, which are the two to go to 6 and go to 7. The routes go to 8. It cost now became 3 because you changed the metric in. So it will not be the best. So metric out, the other way is you can change the metric when you advertise. The metric in is change the metric when you receive it. Metric out is change the metric when you advertise it. So for this topology, we will change the metric out on R7 interface gig 000. So now on R5, you should only see one route. So you only see one route facing the go to router 6, because you changed the metric out. So on R5, the path go to R9 is not the metric is not 2 anymore, because you change the metric when you advertise. Split horizon and Poisson reversed. These two commands can be configured under the interface. So the command is rip split horizon and rip Poisson reverse. If both are enabled, only IP Poisson reverse will take effect, and the rip split horizon will be disabled. This is on the AR2200. Now we can check the status of the rip and their interface. So display rip 1 interface E002. So you can see the state is up, MTU on 500, metric in is 2, metric out is 1. So rip version 2 multicast, poise reverse enabled, and split horizon enabled. So be careful, both show as enabled, these two things, but only Poisson reverse will take effect. Rip output. You can disable the rip output under the interface. Remember, now we have only one route go to 9 from R6. So now we will disable the output on this interface. Let's see what happens. So now on R5, you can see the in order to go to 9 network, you go to R8. Even R6 has a better metric, but we configure this interface doesn't allow R6 to advertise RIP message to R5. RIP input. You can disable RIP input under interface. So again, let's check the routing table. We learned the route from R8. Now we can configure this interface R5. Interface gig 0/0/2. We put RIP. And do RIP input. Now we don't see any route because we disable the routing information on this interface. So any RIP, this R8 still advertised to this R5, but R5 have command to disable the RIP input. So since we disable the RIP input from R8, now you can only see R7, which used to be the highest cost. Now that's two better routes. We already on one link. Here we put undo RIP output, so R6 will not advertise to R5. On this side, we put undo RIP input, so we disallow this interface to learn RIP. So now only R7 can advertise. See, we have only one route to 9 network through R7 with cost of 6. And we already configuration validation. Let's run the command. Display RIP 1 interface 0/0/2. You can see input disabled, output enabled under this interface. Silence interface. So under the RIP, you can silence interface. So basically, the interface will not participate in RIP, but will still receive RIP routes. It has higher priority over RIP input and the RIP output commands. So same technology topology on R9. On 9 we have two routes, two paths to 5 network. 5 is R5's loopback address. So we can go through R6, R7, and R8. Now we will silence these two interfaces on R5. So on R9, when the network converged, you can only see one route learning from R6 because we silence these two interfaces on R5. But on R5, you still should be able to see the traffic, the routes advertised from, you see the from 7. You still see the routing information coming from R7, even we silence this interface. So silent interface will only basically disable receive the RIP routes, but it should be able to still advertise. Display RIP. So we should be able to see silenced interface 2 and 1. Questions. At which point is the metric incremented for advertised routes? So basically the metric is incremented prior to the forwarding the route advertisement from the outbound interface. What configuration is required in order to advertise RIP routes? Through the configuration of the network command. Remember, you go to RIP space 1, you enter, you go to the RIP view, and from there you type the network command. For each network that is to be advertised by a router, a network command should be configured, and it should use a natural form, which is the class 4. You use the class 4 network. Thank you for listening.